Hello guys, in this video we are going to discuss the solution of the problem sequence of sequence. So let us look at the problem statement. So the problem statement says that we are given two integers m and n. Try making a spatial sequence of numbers sequence of length n such that these conditions hold. Okay, so these conditions hold and your task is to determine total number of such spatial sequence. So let us understand the problem with the help of an example. Let me switch to this. Okay, so let us take an example. So here two integers which are given to us is basically n, which is equals to 4, and m is equals to 10. So using these two sequences, so what does this n means? Well, n simply means that we have 4 places with us. Okay, so let us consider it like 4 boxes are available to us, and in each of these boxes we have to plug some numbers. And what are those numbers? Well, the numbers are the special condition which is mentioned in the question. So let us see what are those cases. Well, the case says is basically like one such sequence is basically, let me just call it as S1, is basically 1, 2, 4 and 8. Okay, so here if you see, this is less than or equals to this. So basically this number, twice of this number is less than or equals to this, right? Similarly, twice of this number, 2, is less than or equals to 4. Similarly, twice of 4 is less than or equals to 8, right? So that is the special condition which was mentioned in the problem, that is the twice of this number. The twice of the first number should be less than or equals to the second number. So if you take 1 and 2, then twice of 1 is less than or equals to 2. If you take these two numbers, then twice of 4, which is 8, is less than or equals to 8. So how many such sequences can we make is the task we have to find out. Okay, so for instance, in this particular case, the sequences, the valid sequences are, okay, valid sequences are, so one valid sequence is the above one, 1, 2, 4 and 8. Another valid sequence could be 1, 2, 4 and 9. Another valid sequence is 1, 2, 4 and 10. And another valid sequence is 1, 2, 5 and 10. Okay, so these are the only valid sequences which is possible, and the total number of valid sequences are basically 1, 2, 3 and 4. Thereby we are going to return 4. Okay, so let's take one more example in order to understand this problem. So in this example, let us say m is equals to 5 and n is equals to 2. So the number of boxes which are available to us is 2. In these two boxes, we have to find spatial sequences, the number of spatial valid sequences which we will be able to make. Okay, so in this, for this particular case, the valid sequences would be, okay, so the valid sequences would be 1 and 2. And if you see, the twice of first number is less than or equals to the second number. Another valid sequence would be 1 and 3. Again, the twice of first number is less than or equals to the second number. 1 and 4. Again, twice of first number is less than or equals to the second number. Similarly, 1 and 5, 2 and 4, and 2 and 5. So these are the valid sequences which we have, and let us count the number of valid sequences. Well, the count is 2, 3, 4, 5 and 6. So in this particular case, we are going to return 6. So that's about the problem statement, folks. Now let us understand, let us discuss the solution for this. In order to discuss the solution, let us take the first example which we have discussed, where the value for m was 10 and the value for n is 4. Okay, so we have 4 boxes and we want to fill values in these 4 boxes. Okay, so let us try to find out the range of all these boxes. Okay, what will be the range of this box? What is the range of this box? Okay, so let us try to find out the range of individual boxes. Okay, just write it down. So let me say that this is my box 1, this is my box 2, this is my box 3, and this is my box 4. So in any sequence, if you see the in any valid sequences, if you see the last element of the valid sequence, so let us take this, the last element of the valid sequence, if you analyze this, those are 8, 9 and 10, right? So what we can infer from here is basically the last element of the valid sequence would be at most m, right? The maximum value it could attain is m, right? Here in this particular case, m was 10, right? If you see this, m was 10. So let us discuss the range. So as we have seen in the example that the maximum value which the last element could attain is m itself, right? So in this particular case, m is equals to 10, so the maximum value is 10 in this particular case, right? Now let us see what is the minimum value, right? What is the minimum value for the last box? Well, the minimum value for the last box will be such that if we plug that value over here, right? So let us say the minimum value for the last box is x. So if I plug that value over here, then the third box should be x by 2, right? And the second box should be x by 2 square. Okay, and the first box should be x to the power 2 cube, right? And now this x to the power 2 cube, what is the minimum value it can attain? Well, the minimum value is 1 itself, right? So in that way, x is equals to 2 to the power 3. Okay, so let me go over it one more time. So the minimum value, let us say the minimum value box 4 can attain is x. If x is the minimum value box 4 can attain, then the maximum value box 3 could attain is x by 2, right? Because remember the condition, twice of third box should be less than or equals to 4. So the minimum value it could attain is x by 2. Similarly, the minimum value the second box could attain is x by 2 square, half of x by 2, right? And similarly, the minimum value the first box could attain is basically half of the second box, which is x by 2 cube. Now the minimum value could be 1, so x by 2 cube should be equals to 1, which simply means x equals to 2 cube. Okay, so for this the range is 2 cube. So if you see, the range is basically here 8 to 10. Okay, once we have identified the range of the last box, it is very easy to identify the range of all other boxes. The reason is basically the relationship between the two boxes is basically like if box 4 is of range 8 by 10, then the third box range should be half of this, right? So the third box range will be 4 to 5. So following the similar logic, what should be the value for valid range for second box? Well, the valid range for second box should be half of this, which is 2, and the half of 5 is also 2, right? So we'll take the the floor function. Over here the half is 1 and 1. Okay, so these are the valid ranges. So we understand that the valid ranges are these. Okay, now since we took a concrete example, I gave the ranges as such. Now let us let us generalize this. So what I am going to do is basically I am going to write the above range in the form of n and m. Okay, so the valid range for the first box, if you remember, right, it was basically 10, which is the last element, right? So the last element is what? M, right? Which is given by M. And what was this? This is basically 2 to the power 3. Okay. So let us see what does 2 to the power 3 gives us. Okay. So this is 2 to the power 3. So if you see, we started with x upon 2 to the power 0. Okay. Then we x upon 2 to the power 1, then x upon 2 to the power square, and x upon 2 cube, right? And what is this? Basically, these are the number of boxes. Okay, right? The number of boxes, and the number of boxes has come from n, right? So what we can do is basically this 2 to the power 3, what we can write it down is 2 to the power n minus 1. All right. So for box number 4, which is the last box, the valid range is 2 to the power n minus 1 to m. Okay. For box second last box, the valid range is 2 to the power n minus 2. 2 to the power n minus 1 divided by 2 is basically 2 to the power n minus 2 to m by 2, right? So for this, the valid range is 2 to the power n minus 3 comma m upon 2 square. And for the first box, the valid range is 2 to the power n minus 4 upon m upon 2 to the power 3. Okay, so I hope this concept is clear, right? This concept is what we are going to use when we will code. Okay, so now, so have we once we have understood this, now let us see how will be using this concept in order to solve our problem. So let us take the same example. So m is equals to 10 and n is equals to 4. So to understand it, let us see we are at n is equals to 4, and the range for the last box, as we know, is basically we know that it is from 8 to 10, right? So the valid ranges here is basically 8, 9 and 10. Okay, so what I can do is basically I can try to form a valid group using element 8. Similarly, I can try to form a valid group using element 9, and I can try to form a valid sequence using element 10. Okay, and here once I have consumed 8 or 9 or 10, so I'm going to reduce my n, and n becomes 3 here, right? Because for the last box I have put a value over there, right? It could be either 8, it could be either 9, or it could be either 10. Okay, now we are at third. So for the third box, what is our valid range? For the third box, the valid range is 4 and 5. Okay, so let us say for third box our valid range is 4 and 5. 4 and 5. 4 and 5. Okay, so now what can happen is basically 8 can pair with 4 and 8 can pair with 5, right? Similarly, 9 can pair with 4 and 9 can pair with 5, and the same thing goes for 10. So let us try to pair all these possible values. So okay, let me just have it over here, right? Okay, so if you try to pair, see, 4 and 8 can be paired together because twice of 4 is less than or equals to 8, but we can't pair 5 with 8, isn't it? Because twice of 5 is 10, which is not less than or equals to 8. So the valid value over here will be 4 and 8. Okay, similarly, so 5 and 8 is not possible. Similarly, over here also the valid value is 4 and 9. 5 and 9 is not a valid combination here. Here also, here if you see, we can pair it with 4 as well as with 5, right? So the valid combination over here is basically 4 and 10. Okay, and the other combination is 5 and 10. So these are the two combinations which we could have, right? So as soon as we have consumed the third box, then now here n becomes 2, And for second box, what is the valid combination? Well, the valid combination is just 2, or the valid range is just 1, which is 2, right? So the valid range over here is just 2. Now let us make the combination. So now here 4, 8 and 2. Oh, I'm so sorry. This is, let me just write it down. So with 2, it makes a valid combination, right? Twice of 2 is less than or equals to 4. So 2, 4 and 8 is a valid combination. Similarly, 2, 4 and 9 is also a valid combination. So 2, 4 and 9 also forms a valid combination. And 2, 4 and 10 also forms a valid combination. And similarly 2, 5 and 10 also forms a valid combination. Okay. Now the next one, okay, I think I ran out of space. Okay, so let me just write it down over here. Now as soon as we have consumed the second box, so n becomes 1, right? So now again, so if now what is the for first box, what is the range? So for the first box, the range is 1, right? Just 1. So let's have that. So for the first box, the range is 1. This is also 1. This is also 1. And this is also 1. Okay. So now let us make the valid ranges. So the valid range is 1, 2, 4 and 8. Here the valid range is 1, 2, 4 and 9. Here the valid range is 1, 2, 4 and 10. And here the valid range is 1, 2, 5 and 10. And if you count the number of valid ranges, this is 1, 2, 3 and 4. Okay. So this is the logic behind it or the conceptual understanding of it. Now let us see how we are going to code this understanding in our in Python. Okay. So what I have done is basically, so first I have iterated on, so what we can do is basically for I in range n. Okay, so the number of boxes, right? And so this is basically number of boxes. So we are iterating from first box to all the way till n box. Now if we are at first box, we know the range, right? So the starting range is what? If you see this, we have written it over here, right? So if you remember this is basically 2 to the power n minus something divided by m to the power 2 to the power cube. So let us see how we are going to write it. So we are iterating from I, and I belongs from 0 to n minus 1, right? So the way we will be able to do it is basically, what we are going to do is we are going to say that the start is basically pow, or we can write it down as 2 to the power n minus I plus 1, right? And the end is basically m divided by 2 to the power I, and here I is equals to 0, right? So if you see this, right, this start and end, so this, if I is equals to 0, this becomes 2 to the power n minus 1, which is the last box. If I is equals to 1, this becomes 2 to the power n minus 2, which is this third box, and so on. And similarly for end, m upon 2 to the power 0 is 1. So sorry, m upon 2 to the power 0 is m, which is this. Then m upon 2 to the power 2 to the power 1, which is this, right? So the start will be this and end will be that. Okay, so let us write it down. So our start is basically 2 to the power n minus I plus 1, and then we have to use power function over here, so that we will use it, but over here I am writing it down as like this, and end is equals to m divided by 2 to the power I. Okay, and this is an integer, right? So everything is int. And what we will do is that we will take a list which is first, and we will just say it's an empty list. What it basically holds is it will hold the values for, so if you see so we know that for I equals to 0, the ranges will be, the valid ranges we will get is this, right? 2 to the power 3 to 10. So this from 2 to the power 3 to 10, which is 8 to 10. So the values from 8 to 10, right, which is like 8, 9 and 10, this is what we are going to store in the first list. Okay, so let me just write it down. Now there will be a j for j in range, and the range is basically start to end. We want to go all the way to end. Okay, so we will iterate on this, and if we say if I is equals to 0, right? So that simply means the last box we are populating it, the last box valid ranges we have find it out, and we want to put the valid ranges in the first first list. So we are going to append first by j. Okay, otherwise if I have the value of first layer, right? So if you see this, right? So when I is equals to 0, so this is what is the value of, so this is what is the value which is there in the first list, right? So this is the value which we have in the first list. Now when I is not equals to 0, so let us say I is equals to 1, then we have generated this values 4 to 5 range we have generated, mind the start and end variable which we have, and j is the iterating counter. Now what we are going to do is that for each, so for j, right, for j we are going to check if j makes a valid combination with 8 or not, with first or not, right? So that is what we are going to do. Let me just write it down and it will be a bit clear. So now first has been populated. Now what we are going to do is basically we are going to iterate on the element in first. Okay, so let me just write it down over here also so that I'll be able to explain it. So first contains 8, 9, 10, right? And after that we are at I is equals to 1. Okay, let me just write it down like this so that there is a clear distinction. I is equals to 1, so we know that the start is basically what, 4, and end is basically what, 5. Okay, and j is iterating from 4 to 5. So right now the value of j is 4, and we are going to check whether j makes a valid combination with each of the elements of first or not. Okay, so element, and we are going to check if twice of j, right, twice of j is less than or equals to element. If it is so, then it makes a valid combination. So what we are going to do is basically we are going to have a temp, and we are going to append j into temp. Okay, and I'll explain why I'm using temp, and we will keep temp as here. Okay, an empty list. So that is the case. Now what will happen is basically once the j loop ends, right, once the j loop ends and I is equals to 1 and j loops end, then in the temp we will have values which makes a valid combination with the first element. So let us understand what do I mean by this. So in this loop, right, with this loop we will check whether 4 makes a valid combination with 8. So it does. So I'm going to append 4 to temp, right? Now again I'll check whether 4 makes a valid combination with 9. It does. So I'm going to make it as over here. Again we'll check whether 4 makes a valid combination with 10. It does. So I'm going to append 4 here. Similarly, when now j is equals to 5, I'm going to check whether 5 makes a valid combination with these. Clearly 5 does not make a valid combination with 8 or 9, so we will have just one entry of 5 in temp. Okay, so in that way I understand that I am able to obtain this set. right? If you see this set 3 times 4, let me use a different ink here. So this set I am able to find out. Okay, and since I don't need all the elements of the set, I just need the most recent element, and that is why I'm maintaining that most recent element in the temp list. Okay, so 4 4 4 and 5 is something which will be there in the temp list. So once this is done, what we are going to do is basically so this is my for loop. Let me just have it like this. So this is my for loop, and over here I'm going to say that if temp has been populated, then first is equals to temp. Okay, why I'm doing it? This I am doing it because in the next iteration I am going to what we want to do is basically we want to check whether this, so remember this is already there in the temp, which, right, so this is there in temp, and I want to check whether this makes a valid combination with these values, right? So for that reason I'm going to copy this temp into first, so that I could, so basically here if you see, right, first, so that is why we need to update first. Since we have to update first, and what should be the updated value? Well, the updated value is in temp. Okay, so that is how it is, and towards the end what we are going to do is basically we are going to return the length of temp, first. Okay, towards the end what will happen is basically the first will contain 1 1 1 something like this, and the length will be 4, and that is what we will return. Okay, so that's about the explanation and the coding aspect of it, folks. Now let me run it, and okay, so that's the code. So it's the same code which I have explained it over there. Now let me just submit the solution. So our solution got accepted. So that's about the video, folks. In case if you have any comment or question regarding this video, please feel free to drop it in a comment and I'll try to address them. Thank you.